Hello there, good morning. We are doing valid palindrome. In this particular problem, we are given a string, a phrase, and we need to reduce it to alphanumerical, reduce it to alphanumerical characters, and check whether or not it reads the same forwards or backwards when it's lowercase. So the method is what we'll be using is two-pointer. So let's check that out. Let's start with race car. Let's have a left pointer and a right pointer. If the left pointer and the right pointer are equal, we can squeeze in both ways, whether it be even or odd. We can make sure that the middle item are equal, and then when they cross, we know that these items it is a palindrome. Actually, we don't even need to check whether it is equal in the middle. Once it meets in the middle, then of course it's a palindrome. However, if suppose they are not equal once we reach this particular point, then we can return false. The method that I'll be using is to use a function to analyze every single character. And this way we just do the operation, we do one single loop through all the characters. Another way to do this is to filter out everything and do two loops. As you will see later, by doing these two methods, we'll find that actually both methods present us with the same amount of runtime for some reason. And I think that reason is going to be because we access the function once rather than multiple times. Let's check it out. So first of all, we need a left and right pointer, which starts at 0 and the length of string -1. Another thing that we need is, well, I think we just need a while loop. Left is less than right. Yes, and then if, let's say, string of L dot is alphanumeric. This is a function that we have. We make sure this is not alphanumeric. Then I plus equals 1. Then we move on and check the next character. Else if not S of R dot is alphanumeric, then J minus equals 1. Else if S of L dot lower is equal to S of R dot lower, then we move both forward. Otherwise, they're not equal, and then we can return false. Otherwise, at the end of the day, we go through all the items and we can return true, and let's run the code. Shoot, I did the I thing again. Okay, no problem. Alright, it looks good. Let's submit. Alright, the memory usage is much better in this particular case because we're running it one loop. The runtime is pretty good as well. And we are just using the same string. However, if we want to reduce the number of function calls, we can just do an S is equal to dot empty string join with a filter on the string dot is alphanumeric, and we'll use string, and we'll do a dot lower on it as well. And this way we can skip everything. We can just have an if else. Yeah, so let's run it and submit. Oh, whoops, we did not need these lower functions here. But as you can see, the memory usage is much higher because we made another string. Also, the runtime is pretty much similar, I think. There's not much of a difference here. But I think the code is simpler. Let's see which way to write this code would be simpler to read. Oh, whoops. Right. My bad. Let's submit that. So, I mean, I think, if anything, we should write this code instead because it uses less memory and it has almost practically the same runtime. We should not do the join and filter method. We should just do one single loop and create a filter while we look through the items. This is pretty good. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.